Welcome everyone. Today we're here to talk about cost management with Databricks SQL. We'll share some tips and best practices on monitoring and optimizing your DB SQL build, as well as demos to show you how to actually do it and take it into effect in your deployments. My name is Juho, product manager on the DB SQL warehouse management and monitoring team, joined here with Patrick, who is a staff software engineer and one of the tech leads on our team. Before we start, just some housekeeping notes. Some things we will share today here are forward-looking and may be subject to change. And at the end of our presentation, we'll have a survey for you to fill out. Before we dive into the how, let's first discuss why. Why does DB SQL cost governance matter? And to answer that question, let's start with what your deployment may have looked like on day one. Maybe you had one workspace with a starter warehouse, a couple analysts are running notebooks on it, notebooks to query some information. The value is limited, it's a great start, but you had very simple cost governance. When the bill went up, it's very easy to understand why it went up and what the next steps to take are. But today your deployment looks a little bit different, probably something like this on your right. You have multiple workspaces, you have multiple warehouses, your marketing team is using Tableau dashboards for one warehouse, you have another set of users querying using SQL Editor, perhaps on the same warehouse or a different warehouse. There's a lot of value that we are helping you deliver to your organization, but cost governance becomes very complex here. You can't just look at your bill to get all the answers for questions like who used what, how much, and why did my warehouse bill just go up by 20%? So we're here today to guide you to simplify cost governance so you can continue on focusing on bringing value to your organization with DB SQL. We've split today's sessions into two parts. First, we'll help you understand your bill at each level of granularity from the account level all the way down to the usage level. We'll also cover how you can do this proactively and continuously throughout your day. Then we'll show you how to optimize your DB SQL usage, how to optimize warehouses, users, queries, and tables, so you can get the best performance on every dollar you spend with us. And at the end of each session, Patrick will do a quick demo on how you can do this today. So before optimizing or scaling your usage, you have to first understand what your bill is today to set the baseline. And the bill should be more than just a number. It should give you insights on how you're using DB SQL today. And we want to help you slice, attribute, and monitor spend at every level to help you fully grasp your DB SQL usage and be able to evaluate it. So let's begin. But the first question is, where should we even start? We're simplifying this for you and suggesting that you start from the top at the account level. Follow the guide on the left-hand side as we walk through cost monitoring step by step. So we recommend starting at the account level to get a bird's eye view of all your warehouse spend across your workspaces. Find where the anomalies are and where it's worth your time to double-click and investigate further. You have two key tools here. First, on the left-hand side, the account usage dashboard. This gives you a high-level visual breakdown by workspace and warehouse, and you can set this up very easily in the account console. On the right, you have system tables. If you want more control or need to customize reporting, our building system tables let you write SQL queries to analyze spend by any grouping of warehouses that you want. Covering the basics here, hope all of you know this, but the best practice for cost governance is to apply custom tags to your warehouses. So for example, if the marketing team has 4 warehouses, tag these warehouses with key team and value marketing. And then these tags will propagate to the system table and the dashboard that we just covered, and you'll be able to monitor all those costs together, so you can do things like showbacks, chargebacks, or just understand how each team's costs are trending over time. So now you've identified that the cost of this specific warehouse is going up. Are we done? No. You still need to understand what's driving it. Is it Patrick? Is it Power BI? Or is it a specific AI BI dashboard? But then you may ask, isn't billing at the warehouse level? How can I get from warehouse level costs down to the specific user or dashboard's costs? And that's right. Databricks charges for warehouse uptime. So in the billing system table, you'll find a row which has the billing information for that warehouse. But the good news is that with the other system tables that have query level information, like the query history table, you can approximate the query attribution very simply by using these tables. For example, if a query took 2% of the warehouse's compute time, it will be attributed with 2% of its costs. And we've made this even simpler for you with the DB SQL cost materialized view that you can find in our Databricks Labs GitHub repo. And we'll walk through a demo of how to use that. So now we've taken costs from the warehouse level down to the query level. But it's very unlikely that a single query is driving up all of your warehouse costs. So how do we get to the cost drivers? How do we get to the root of the drivers of cost? Again, is it Patrick? Is it Power BI? How do we get to that? And this is where the DB SQL cost dashboard comes in, which is also available in Databricks Labs GitHub repo. And this gives you the three views that you care about. How do I get my top users, top tools, and top Databricks assets? Now you can understand who, what, why are your costs changed, and also use this dashboard as a starting point to manage the costs. We'll do a quick demo on that shortly. So great. Now I want to do this proactively and continuously, because I don't want to be staring at my screen 24/7. And we got some solutions for you here as well. On your left-hand side is budgets, our out-of-box solution. So if the team's monthly BI workload should be $1,000, you can set a budget using the workspace and tags that match to that team's BI workloads to monitor progress and be notified when that $1,000 budget has been exceeded. On the right-hand side is our alerts product, and you can use this for custom notifications. So tying this back to the cost per query materialized view that we discussed, you can set it up such that the alert will notify you when any user's usage exceeds $100. We'll cover this in our demo as well. All right.
All right, thanks, Juho. So yeah, I'm going to walk through a couple of the items that Juho just presented. So for starters, before we get started, as Juho mentioned, some of the tooling that we just presented available to you, like the materialized view for granular query costs, as well as the dashboard that uses that materialized view, are available currently in the Databricks Labs repo. So this is currently because it's in private preview. So you'll have to access the repo and essentially mount them yourself. But it's pretty straightforward to import this dashboard and recreate this materialized view. So yeah, if you need to do so, it's in the Databricks Labs sandbox repo. It's pretty easy to find on Google as well. So yeah, why don't we jump into a usage example? So I've already gone ahead and imported both the materialized view, which remember, it takes both the billing usage system table as well as the query history system table and combines them to build a cost per query model. So I've taken that materialized view, imported it into my Databricks account. I've also imported the dashboard that Juho was just mentioning, which uses that materialized view. And this dashboard is really cool. It allows you to kind of do this sort of slicing and dicing of the data that's present in the materialized view based on a couple of different dimensions, right? So for example, we can kind of slice by like cost per user. We can slice by source type. We can also slice by object source ID. So source type is going to be like what tool it could be. So you're seeing some Databricks native tools like AI BI dashboards and SQL queries, but also like external tools such as like Power BI or Tableau. And then the source object ID is going to represent, if it's an internal, Databricks asset, what's the ID of the asset, right? And then also it gives you kind of this breakdown based on all the queries that it sees in this materialized view, like the attributed cost per query, right? So I'm going to quickly walk you through an example of like, let's say I want to do a little drill down. And note, this is an AI BI dashboard, so you get the full power of kind of like the features that the AI BI team is working on to kind of like make it a lot easier to investigate these sort of items. So for example, maybe I want to take a look at this user. Oh, look, it's Juho, right? So like, let's take a look at what Juho's been running on top of this workspace, right? So if I click this, you'll notice that all the AI/BI goodness is happening. It's cross-filtering across all the other visualizations, and he's mostly been running AI/BI dashboards, right? In particular, this dashboard, right? So this dashboard is kind of interesting. So let's kind of filter through that to take a closer look. So by doing that, you'll notice that all of the queries that are in the statement level detail portion of the dashboard have been filtered to just that dashboard. So we can take a look at the individual queries, maybe see if there's some hot queries or something like that from this dashboard, see what's going on here. But for now, for the purpose of this exercise, what I'm going to do is I'm going to scroll over to here, which populates that query source ID, which again is representing the ID of the dashboard that executed this query, right? So this is a hot link. So like I can press this link. I'll be brought over to an actual dashboard definition. And here I can take a look at some of the dashboard. Maybe some parts of the dashboard are loading slow, or maybe it's like a really aggressive schedule. So in this case, I'm going to happen to take a look at the schedule button here. So we'll notice that hey, Juho put an hourly schedule on this dashboard. That's a little wasteful, right? So why don't we go ahead and edit this dashboard schedule to reset this to maybe once a day. I don't think Juho needs to get hourly freshness on his dashboard, right? So I can save this. If I want to be really aggressive, I could even go in and pause it, but I'm going to be a bit nice. So I'm going to keep his schedule for that there. So, but yeah, this is just like one quick example of like a walkthrough of like what the power of this like materialized view and this new example dashboard can do, right? It allows you to do all these sorts of like investigations and drill downs much easier. All right, so the next thing I wanted to show off is going to be at the account level. So we talked about budgets and the new budgeting tools that we provide you at the account level. So if you're familiar with the Databricks account UI, you might be familiar with this page. This is the account home, right? This is where you go if you want to manage your warehouses, or sorry, your workspaces, excuse me. So for this one, we're gonna take a look at the usage tab, right? So if we go into usage and we go into budgets, you'll see that you can provision these budgets essentially, as Juho mentioned, by going to this button here, and then setting, for example, like a specific amount you want this budget to represent, right? This is going to represent the limit per month of the spend that you want to monitor here. So let's say I want to do it for 1,000. Let's call this like my new demo budget. And then, okay, normally you can select which workspaces are available here. So let me maybe just do a quick refresh. It's because I didn't log in. Sorry about that. Yeah, so let me just redo that really quickly. So demo budget. And then I can select which workspaces I want this budget to apply. So maybe I'll just have it for all the workspaces. And then as Juho mentioned, the best practice is to always tag your compute resources to make sure that you're only you might want to tailor your budget to a specific team or something like that. So we can do something like team marketing. So we're just targeting the marketing team's warehouses. And then we can also add an email here. So this email will just be used when the budget is breached to kind of send a notification to that email to say, hey, by the way, you should take a look at this budget. We just went past the limits. So maybe I'll send it to myself, right? Okay. So created the budget. It takes a bit of time to populate. So in the interest of time, I have a couple of examples here that I've set up previously. So when the budget's fully formed, you'll notice that you get this really cool burn down visualization essentially that you can track for how quickly are we burning through our budget on a daily basis. Nice metrics of okay, we have this much remaining, this much spent, and the run rate. And just to show you an example of what an exceeded budget email might look like, I have this example in my inbox, right? So you'll see that we'll send you an email that says hey, based on this budget name, and then based on this budget amount, we just exceeded it by this %, as well as a quick detail of hey, this it was because this budget was exceeded by this workspace, right? All right, so the last thing I wanted to show off was, kind of the fact that, by providing you the details in system tables as well as our materialized view that uses the existing system tables, we're doing this very consciously, right? Because we're putting this on top of Databricks, right? Which, in my humble opinion, is the best data analytics platform in the market, right? So what that means is that you can use all the power of Databricks to kind of customize your budget analysis, if you will, right? So for example, in this case, I'm going to show off a bit about the new Alerts v2 beta that we're just launching. But you can use the Alerts v2 to kind of write queries on top of this existing data. Remember, it's just data inside of your lakehouse, right? So right now I have this, this alert set up. If you take a look at the query here, what this query is basically saying is that if any users query usage dollars estimation is above 10 for the last 30 days, I want to send an alert, right? I want to send a notification to an email or a page, a Slack or something like that, right? So we have this configured, and yeah, just wanted to show you this quick example of just one way that you can use the power of the existing Databricks platform to do budget analysis, right? And with the rest of the tools in the platform, like notebooks or dashboards or etc., let your imagination go wild with however you want to customize this behavior. So, all right, back to you, Juho.
All right. So we also have some additional features coming soon to make DB SQL monitoring experience even more powerful. First thing is schedules. So as Patrick walked us through in the demo, it is possible to infer some of these scheduled workloads from the cost dashboard that we have available. But it's still hard to see all this in one place and also see data including hey, is this schedule at the hourly level, who owns this schedule, etc. Next quarter, we're building out system tables for all first-party schedules that will let you do this, and you will be able to attribute costs to each schedule and navigate to the parent asset, like the notebook or the job, to manage it. Next is query labels. So sometimes the dimensions that we provide you, like user ID or client application, is not sufficient for your cost monitoring needs. Maybe you need to understand, hey, which queries are coming from a specific Tableau dashboard or a specific project, and do cost monitoring at that level. And with query labels, which we are building out, you will be able to do this. You'll be able to apply optional query labels to each query execution, both from SQL language and directly from these external tools, so that you can get the cost attribution at those levels. Cool. So now we have some tools. Now hopefully you know some tools to understand your bill, but that's only the first step. This section will be on how you can optimize for better ROI, so what are the steps to make your deployment even more effective? So where do we start here? And here are the 4 levers that you can play with for optimization: warehouse, user, query, and table. And it really depends where your deployment is most unoptimized. But we'll cover all these 4 bases. Let's start with the warehouse level, because the settings here that you set at the warehouse level can make or break your bill. I'm sure this is obvious, but the warehouse settings contains levers to control your spend. You can set your hourly spending limit with the t-shirt size and max cluster count. So for example, if you're using an Excel warehouse with 2 max clusters, 2 times 80, 160 dBs per hour will be the max spend limit for your warehouse. You can also use auto stop so that you can reduce warehouse uptime when there are no queries running. And lastly, we have serverless, which is our SKU of recommendation for both best price and performance. So now that we understand some of these levers, how can we use them to optimize warehouses? So first of all, serverless SQL warehouse. First of all, start with serverless SQL warehouse. With serverless SQL warehouse, you can get up to 2 times the performance compared to Classic and Pro. So serverless has all these features on the left side that lead to cost optimizations on the right side. With faster startup times within the magnitude of seconds compared to minutes for Classic and Pro, you can set a more aggressive auto stop, which will reduce warehouse uptime. We also have intelligence workload management. So using AI, we are directing queries to the optimal clusters for query performance. And this, you get automatically improved utilization, which leads to cost benefits as well. Lastly, we have faster auto scaling. So instead of creating multiple warehouses, you can consider merging warehouses and let us do the horizontal scaling for you. With this, you'll get a reduced TCO and with auto scaling. Another step is to look at your current warehouse to understand where there are opportunities for optimization. So as you all know, we have our monitoring UI as well as system tables to provide all these bits and pieces you need to evaluate your warehouse performance and where there are room for optimization. For example, you can understand when is my warehouse experiencing repeated queuing? Are my clusters reaching the max cluster limit? And what is the P95 latency of my workloads, and how is this changing week over week? So with this information, you can choose the right size for your warehouse. Just to note that everything about right sizing is a trade-off between performance and cost. If you're experiencing that the workloads are slow and they're not meeting the SLAs of your organization, consider increasing your t-shirt size and max cluster count. If you're constantly meeting the upper limit of your budget, then consider reducing t-shirt size and setting a more aggressive auto stop. Also monitor for how your P90 latencies are changing so you know that the performance degradation is manageable. Lastly, if you're experiencing that P99 queries, like a handful of long unoptimized queries, are degrading your performance, instead of trying to change warehouse configurations, your best bet will be to optimize these queries directly, and we'll cover that in the next section. So a common driver of warehouse costs are these P99 queries. These long-running queries keep warehouses up and also hog resources, causing noisy neighbor problems for the other workloads on your warehouse. So how do we solve for these long runaway and unoptimized queries? The first option is to use statement timeouts. So statement timeout will kill queries that go beyond a certain threshold. And it's a great way to manage these runaway queries that do more damage than good for your organization. And today we have these timeouts at the workspace level. The issue is that depending on the workload type, you may expect different amounts of time for the query to compute. So for example, for a BI workload, you might expect it to take 10 minutes versus an ETL workload that you may expect to take an hour. But today we only have this single lever that you can control. The good news is that this quarter we'll be previewing warehouse statement timeouts, which means that you can configure these timeouts at the warehouse level. So you can specify, hey, for this warehouse that I use for my BI workload, set a 10-minute timeout, and then for the ETL warehouse, 2-hour timeout. The other option to address these queries is to optimize them. And there's two options here. So the first one is on your left. You can ask Assistant to help you optimize your query. You can do this before and after an execution, and Patrick will do a demo shortly on how to do that. The second is the more advanced step of using query profile to find bottlenecks. So recently we did a revamp of this UI, and now we have the new top operators panel surfaces. That new panel that surfaces the bottlenecks and the hotspots in your query right away, so you can jump in and debug it there. So now that we've optimized warehouses and queries, the job is still not done. Many of you have multiple warehouses, and governing how users use them correctly is a core part of the complexity of cost governance. Are users accidentally choosing to run small interactive queries on large warehouses provisioned for critical ETL workloads? Are these queries keeping large warehouses up and making cost isolation difficult? To address that issue, we've started to preview default warehouses. With the new default warehouse setting, admins can configure the warehouse users will be pre-selected to for their interactive SQL workloads. When a user creates a query in the SQL editor, the default warehouse that you choose will be selected automatically. Users can also override this and set, for example, if they have a warehouse provision for their team or their specific use case, which is likely for the power users. So with these two levers, we're providing flexibility and control at the same time. All right, what if you want to go more? What do queries also have in common? Tables. Can tables be optimized? There's 2 steps here as well. So the first step on your left side is to use manage tables to get predictive optimization. So instead of having to manually run commands to optimize your table, we'll do it for you and intelligently when the ROI is right for you. And through automated statistics and automatic liquid clustering, customers can get up to 20 times query performance improvement with predictive optimization. The second option is for more manual optimizations. Using system tables, you can identify which tables are the common source of long queries. So we have lineage system tables that show for each query which tables were read, and we also have the query history system tables that show, hey, which queries are the long queries. By using these 2 tables together, you can identify which tables are creating are the common source of long queries. And one thing that you can do is that if you identify that joins between several tables are the root cause of your long queries, you can consider creating a materialized view so you can cache this expensive part rather than having to rerun this time after time. All right, back to Patrick for the demo.
Cool. Thanks, Juho. So yeah, I'm going to show off kind of a subset of what we just talked about, or what Juho just talked about. So first off, I do want to show off our new default warehouses, mechanism. Back to the Databricks workspace. If you go to the settings panel, and if you go to the compute section of the workspace admin, you now have this new setting here called default warehouse, right? And what this will do is, as an admin, you can set this warehouse to whatever you feel most comfortable with. Generally, what we'd recommend is something like a 2x small or an extra small, right? Because what this is going to be used for is essentially when a user goes to open a new asset, like they want to do some ad hoc querying, that warehouse is going to be populated automatically, right? We're not forcing them to use that warehouse, but if they're not thinking about it, it's best to put it on something that doesn't impact the rest of your workloads, right? So now that we've set it to WHM team, if I go to the SQL editor and I create a new query, you'll notice that, hey, it's all populating to WHM team. Previously, if you've used the product before, you might know that it does this, it used to do this alphabetically, so it's nice that you can kind of select which one you want users to kind of run their ad hoc workloads on. So that's pretty nice. Pretty nice quick optimization. So, all right. So moving over to kind of the warehouse monitoring aspect. Here we're at the SQL warehouses list page. If you've used Databricks SQL or you've tried to manage Databricks SQL before, you've probably seen this before. So we're going to hop into one of these warehouses. This is the panel that you use to manage your warehouse. And if you've looked at the execution stats for your warehouse before, you might have seen the monitoring tab before. The thing I want to highlight here is that the team has done a really great job over the last year, kind of adding a lot of new features to this monitoring tab. So it's way more powerful than it was last year when we were presenting this. We have charts that kind of represent the peak query count. So this is meaning at any given time, how many queries are running on the warehouse. The completed query count. So basically, in a given time window, how many queries were completed, as well as the number of running clusters at any given time, right? And I do like to show off that we did some really cool work to for example, make the cursor, the crosshair, follow when you're scanning through. So for example, it makes it really easy to compare hey, when this peak of queued queries was running, what was the cluster looking like, or what was the cluster count looking like, what was the completed query count looking like. You can compare these numbers really quickly, as well as this really cool, if you do a cross drag, it will cross drag across all of them, but also filter which queries you want to see in the history table underneath, right? So if you wanted to say look at this exact peak, you could filter just that peak and see hey, which queries were on that peak and which queries were completed during that time frame, right? So just to give you a couple of quick examples of what you might look for in this, in these charts, so for example, as Juho mentioned earlier, if you're seeing a lot of query queuing, if this yellow bar is really high and you care a lot about latency, then you might want to increase the cluster count, right? That might be a signal to you that hey, I just don't have enough clusters in this warehouse to fulfill the load spikes that I'm seeing right now, right? And then some other things like, we can also confirm that like, hey, some like Databricks like auto-stop behavior is working correctly, right? Like quickly after the completed query count went to 0, we can see that Databricks, ramped down the cluster to scale the warehouse down to 0, right? So we can confirm that like, hey, all of this is operating correctly, right? It just gives you the confidence to like know that like, hey, all these features that we're talking about up here actually work, right? Cool. All right, and then the last thing I want to show off is going to be kind of the query level optimization techniques that are available to you. So the first one is kind of cool. It's basically kind of like an optimize my query button, right? So I've run this query here, and now we have this button in the bottom right on the SQL editor that you can just press like, and it'll give you some recommendations, right? So we're using the Databricks Assistant, AI tooling to kind of take a look at your query profile and see like, hey, what is going on? Is there something I can change here, that can make my query like faster or like more optimal? So it'll give you some recommendations here. So for example, one common thing that we see a lot of people run into, and this is actually frequently a problem that I run into when I'm querying Databricks internally, is that I'm not adding a filter column, like a where clause for a table that is partitioned by some certain column, right? It's a really good recommendation to kind of do that, especially so you're not scanning the entire 2 years worth of data. You're scanning the week that you need to. So we see the assistant say, hey, it's a good idea to filter data early, right? It'll give you basically an example of an optimized query, and we can kind of take this and you can kind of show the diff, say like, hey, these are the kind of the things that changed about the query text, and then you can also just insert this into your SQL editor and then rerun it as you see fit, right? So for the purpose of time, I'm not going to rerun it. I'm running a bit low on time here, but I did want to show you like if you're, like if you want to go a bit deeper, right? If you're interested in seeing like the internal mechanics of like what's going on in your query execution, you can still investigate the query profile itself, right? So actually, let me see a show of hands. How many people have taken a look at like the query profile, like kind of like the tree view before? Oh, actually, a surprisingly large number. Awesome. Yeah. So I think you'll be really pleased to see that the team did a complete overhaul on the UI and like the UX of the query profile experience. I'm really proud of what the team has done because I think it's just much more informative. It really tells you what's going on much quicker, right? Here's just a really simple like TPCH query, that I ran to give me a representative example. But now we've kind of rearranged some of the statistics here, made it a little bit more easier to understand. But the real cool part is if you open the query profile, we'll highlight essentially the operators that are really important. So for reference, this is the physical plan. This is essentially what the SQL warehouse is like executing in terms of like the physical plan of the query, and we'll highlight the like hotspots essentially. But if you're not really a big fan of like scanning through like large graphs, we basically sorted everything for you. So you could press this top operators button, and then it tells you like, hey, you might want to take a look at this inner join. If you're looking at optimizing the performance or this query specifically, you might want to take a look at this specific inner join, right? So as you can see, it's just a much easier experience. I think it looks much more beautiful than our previous query profile experience, and it's much more intuitive to use as well. So for example, in this case, one usage case might be like, hey, like I know that this inner join is a common join that I do across a lot of my queries, and it seems to be taking a lot of time in this case. So what I can do is essentially say, hey, I'm going to write a materialized view to kind of like optimize this specific join, right? Maybe you don't want to make a materialized view specifically for this query. It might overfit your use case, but if you know that this is a common case across multiple queries, then it might be a good way to optimize. Just say, I'm just going to like cache this specific join, right? Cool. All right, that's all I wanted to show. Back to Juho.
All right, we're almost out of time. So thanks, Patrick. And I hope everyone in this room has learned a couple of things from this talk to make cost governance easier for you. We've given you the tools and tips so that you can monitor and optimize DB SQL costs that match your organization's needs. You can continue scaling with us. Here's a quick recap of all the different features that we covered. Don't think we'll have time to rehash these, but on the left you have how to understand your bill, and on the right how to optimize them. And on the bottom are previews that are coming. So if any of these are of interest to you, please reach out to us through your account teams, and we're more than happy to enroll you in these. Lastly, these are all the other sessions that you may want to visit. The first one on DB SQL What's New, second on specifically improving performance for faster queries, as well as ones around predictive optimization and cost management as well. So please check these out as well. Awesome. Thank you, everyone, and please don't forget to fill out these surveys.